The foundation of Notre-Dame Cathedral was designed to carry a building that did not exist in 1163. By the end of this video, we will answer, where did 100 monks go to the toilet? The flying buttresses that now define the silhouette of the cathedral were added in 1180. They were not part of the original design. They were a correction. Engineers introduced them to stabilize walls that were failing under lateral thrust, the sideways force that Gothic arches transferred downward through stone. This is standard architectural history. What is not standard is the engineering implication. A structure 17 years old does not develop the kind of stress pattern that requires flying buttresses, unless something about the foundation or the load distribution was wrong from the beginning. The official record states the construction began in 1163 under Bishop Maurice de Sully. Local limestone was quarried, masons were hired. The choir was built first, then the nave, then the western facade. This timeline is taught in every architectural survey course. It is printed on the informational plaques inside the building. It is the baseline against which every physical measurement must now be tested. In 1180, 17 years after the foundation stones were laid, the walls began to fail. The solution was to add external supports, arches that carry thrust away from the walls and transfer it into separate pillars planted in the ground. This is the function of a flying buttress. It is a patch. It is evidence that the original design could not handle the loads it was experiencing. But here is the engineering problem. Limestone settles. Foundations compress. Stress distributes over time. A cathedral built in 1163 should not exhibit structural failure by 1180 unless the loads it is carrying exceed the design parameters of its foundation. The stress pattern found in those lower stones is inconsistent with a 17-year-old building. It is consistent with a foundation that was already carrying weight before 1163, or a foundation built to carry a different structure entirely. This is not a theory. This is load-bearing analysis. In 2019, before the fire, a team of engineers from École Polytechnique conducted a structural survey of Notre-Dame. They were not looking for historical anomalies, they were assessing stability. What they found in the lower foundation stones was a stress distribution that implied a phantom load, the residual compression signature left by a structure heavier or differently shaped than the Gothic cathedral currently standing above it. The data showed that the lowest stones had been under pressure long before the upper walls were raised. The foundation remembered a building that the historical record does not mention. After the fire in 2019, the French Ministry of Culture commissioned a full geotechnical survey of the foundation. That survey has been classified. It is not lost. It is not incomplete. It is sealed. The public record contains the restoration plan, the timber analysis, the metallurgical report on the roof structure. The foundation survey is held separately. Access is restricted. This is the point where engineering investigation meets institutional control. One building, two construction layers. The upper structure is Gothic. It is well documented from 1163 to 1345. The stone is local. The joinery is recorded. The architectural style matches the period. The lower structure is something else. The foundation stones are larger. They are set deeper. They show evidence of load-bearing stress that does not correspond to the Gothic arches above them. The tolerance between stones in the lower courses is tighter than the tolerance in the upper walls. This is the opposite of what subsidence and settling should produce. If anything, the oldest stones should have shifted the most. Instead, they are the most stable, the most precisely fitted, the most resistant to the loads pressing down on them from above. The Gothic cathedral and the foundation it stands on are not the same project. They are two projects, separated by time, separated by technique, unified only by the fact that one was built on top of the other. The official timeline does not address this. It states that the foundation was laid in 1163, for the structure completed in 1345. It does not explain why every measurable physical property of that foundation suggests it was built for something else. Material science does not require archives. The composition of stone, the distribution of stress, the geometry of load paths, these are readable directly from the structure. The lower foundation stones of Notre-Dame show microfracture patterns and compression zones that are inconsistent with the weight of the current building. They show the signature of a heavier structure, or a structure with a different center of mass, pressing down for long enough to deform the crystalline matrix of the limestone itself. This is not interpretation. This is standard materials forensics. You place the stone under examination. You measure the load it has carried. You compare that load to the structure currently standing above it. If the numbers do not match, the foundation was built for a different building. The numbers do not match. In modern engineering, foundation performance is monitored continuously. The Millau Viaduct in southern France, completed in 2004, is supported by piers that extend 89 meters below the deck. Engineers embedded sensors in the foundation to measure compression, tilt, and load distribution in real time. The data is archived, the performance is known. If the Millau Viaduct begins to fail, the failure will be documented to the millimeter, and the cause will be identified within days. Notre-Dame had no such system. The builders in 1163 had no way to measure the stress already present in the stones they were building on. They inherited a foundation. They built on it. And 17 years later, the walls began to fail. The flying buttresses were the correction. They were not part of the plan. They were a response to a problem the builders did not anticipate, because they did not fully understand the foundation they were working with. Evidence exists outside the controlled archive. Thermal imaging conducted before the fire revealed unmapped voids beneath the cathedral floor. These are not crypts. They are not documented cellars. They are spaces that appear on no architectural plan. Acoustic surveys detected the sound of moving water beneath the stone, consistent with the existence of channels or conduits running under the structure. In 1847, an engineer named Charles Gourlier produced a map of the subterranean water channels beneath the Ile de la Cité. His map showed a network of man-made passages that predated the modern sewer system, some of which passed directly beneath Notre-Dame. That map was filed in the Archives Nationales. It has never been digitized. It has never been released to the public. It exists. It is not available. The question is not whether the foundation of Notre-Dame is unusual. The question is whether it was built in 1163 for the cathedral that now stands above it. Every measurement says no. The stress distribution says no. The load-bearing signature says no. The thermal scans and the acoustic data and the 1847 map all say no. The only source that says yes is the plaque on the wall, and the plaque was not written by an engineer. It was written by the institution that controls the site. That institution is currently sealing parts of the ancient foundation in concrete as part of the restoration process. This is not preservation. Concrete prevents examination. It removes the foundation from the reach of future investigation. The decision to seal rather than study is not a matter of public debate. It is a scheduled action. Restoration teams are working on a timeline. Certain sections of the lower foundation will be encased and made permanently inaccessible before the cathedral reopens. This is happening now. The medieval canons who lived at Notre-Dame numbered around 100 men at the height of the chapter. They followed the rule of St. Augustine, which required communal prayer at fixed hours throughout the day and night. The night office, called matins, took place in the coldest, darkest hours before dawn. 100 men waking, dressing, and walking to the choir. 100 men who would need to relieve themselves before, during, or after a service that could last an hour. The solution was a structure called a reredorer. It was a latrine block built as part of the monastic complex, positioned at the far end of the cloister or dormitory range. It was not a small room with a single privy. It was a long stone hall with a communal bench running the length of one wall. The bench was pierced with keyhole-shaped openings, spaced roughly elbow-width apart. Medieval latrines were designed for throughput, not privacy. 100 men could be seated simultaneously. The waste dropped through the openings into a channel below. That channel was not a cesspit. It was a flowing water system, fed by the river and flushed continuously by the natural current of the Seine. The Ile de la Cité sits in the middle of the river. The medieval builders used that geography. They cut channels through the bedrock and routed water beneath the monastery, creating a gravity-fed waste removal system that required no pumping, no manual cleaning, and no exposure to open sewage. The system was automatic. The 1847 map by Charles Gourlier documented these channels. He showed how they connected to the river at multiple points, how they passed beneath religious and civic buildings, and how they were maintained by controlled sluice gates that regulated flow during freeze and thaw cycles. His map has never been made public, but the system it describes is consistent with the thermal and acoustic anomalies detected in modern surveys. The monks did not carry candles at night. The rule imposed a period called the Great Silence, during which no speech and no light were permitted. The dormitory, the cloister, and the reredorer were navigated in total darkness. To prevent men from becoming lost or injured, guide ropes were installed along the walls. These were thick hemp or tarred lines, anchored at intervals, that could be followed by hand from the sleeping quarters to the latrine and back. In some wealthier monasteries, polished stone handrails were carved directly into the wall. A man waking in the middle of the night would reach out, find the rope, and follow it. The path was memorized. The distance was known. The system worked because it was predictable. The reredorer itself was ventilated by stone flues built into the thickness of the walls. These were not chimneys. They were passive air channels that allowed sewer gases to rise and escape through louvered openings near the roofline, preventing the smell from reaching the living quarters. Double doors separated the latrine block from the cloister, creating an airlock that further contained odors. The entire system was engineered, not as an afterthought, but as a core component of the monastery's infrastructure. Water flow was the key. In winter, ice could block the underground channels. In summer, low river levels could slow the current and allow waste to accumulate. To manage this, the system included sluice gates, simple stone valves that could be opened or closed to increase flow velocity or divert water from a backup channel. These gates were operated manually by lay brothers, the non-ordained workers who handled the physical maintenance of the monastery. Evidence of vertical waste chutes has been found in the thick walls of several medieval structures. These were stone-lined shafts that dropped from upper-level latrines directly into the underground channels below. Notre-Dame had multiple floors. The canons lived above ground level. Chutes allowed waste to fall by gravity from residential floors into the same flowing water system that served the ground-level reredorer. No buckets, no manual removal. The architecture itself was the machine. Thermal scans taken before the fire showed heat signatures in the subfloor voids that are inconsistent with simple air pockets. The signatures suggest large open spaces, possibly the remains of the medieval channel system, still present beneath the modern floor. Acoustic surveys detected the sound of moving water, faint but measurable, in areas where no modern plumbing exists. These findings were noted in the pre-restoration reports. They were not investigated further. The foundation stones at the lowest accessible level of Notre-Dame reach depths that bypass the Roman occupation layer. Roman construction is well documented on the Ile de la Cité. Foundations from the 1st and 2nd centuries have been excavated in multiple locations. The lowest stones of Notre-Dame go deeper. They rest on bedrock that has no Roman material above it and no medieval material below it. The official explanation is that the 11th century builders dug an unusually deep foundation to ensure stability. The physical evidence suggests they built on top of something that was already there. The stress patterns, the load signatures, the precision of the lowest courses all point to a foundation that predates the Gothic structure by an unknown margin. The institution that manages the site controls what gets excavated and what gets sealed. Restoration is not neutral. Every decision about what to preserve, what to expose, and what to cover is a decision about what future investigators will be able to study. Right now, concrete is being poured over sections of the old foundation. The timeline for reopening the cathedral is fixed. The restoration is on schedule. The parts of the foundation that contradict the official start date of 1163 are being made inaccessible. Not destroyed, not removed, sealed. The question is simple. If the foundation was laid in 1163 for this cathedral, Why does every physical measurement show it was built for a different, heavier, older structure? Official history told us Notre-Dame was built between 1163 and 1345, that the Gothic arches rose on virgin ground, that the flying buttresses were an architectural innovation to solve stress problems discovered during construction. And we believed. To continue believing, you must believe the foundation stones are lying. You must accept that stress patterns frozen in limestone for 8 centuries are misinterpreted. You must ignore the fact that the lower masonry shows load-bearing compression signatures inconsistent with a structure that began construction in the year 1163. The official story is not wrong because of what it claims. It is wrong because of what the stone remembers. The foundation does not revise its testimony to match the narrative. It holds the original specification. The same two-technology signature visible in Notre-Dame is not unique to the cathedral. Walk 400 meters west along the Ile de la Cité. The conciergerie stands with the same contrast. Lower walls of dense limestone blocks, fitted without mortar, achieving tolerances measured in fractions of a millimeter. Upper walls of documented 14th century construction, visibly rougher, joined with lime mortar, built to the standards of the era that claimed them. One island, multiple structures. The same physical division between an ancient lower section and a documented upper addition. The anomaly is not architectural. It is geological. It is a feature of the island itself. The Palais de la Cité, the original royal residence, shows the same boundary layer in its remaining foundations. Restoration work in 1998 exposed a cross-section where medieval masonry sits directly atop stonework of unknown origin. The join is visible, photographed, filed, not explained. The pattern repeats because the platform repeats. Something was built across the entire Ile de la Cité before the official record begins. Notre-Dame was not constructed. It was installed on top of what was already there. The engineering inference is direct. The foundation beneath Notre-Dame required a construction culture capable of hydraulic engineering at a scale that matches Roman aqueduct systems. Structural load calculation sophisticated enough to pre-distribute weight for a building not yet designed, and stone cutting precision that modern diamond saws replicate but do not exceed. That culture is not documented in the official timeline. It does not appear in the historical record of 12th century Paris. It does not appear anywhere in the record of Gaul between the fall of Rome and the rise of the Gothic cathedrals. The gap is 600 years wide. The foundation exists anyway. In 1841, the French Geological Survey published a technical report on subsurface stability beneath central Paris. The report noted an unusual characteristic of the bedrock under the Ile de la Cité. It demonstrated compressive strength and vertical uniformity inconsistent with natural limestone formation in the Seine basin. The surveyors attributed this to an unexplained geological anomaly, possibly related to ancient volcanic intrusion or mineral replacement. They did not investigate further. They measured the strength, recorded the anomaly, and moved on. What they described is not a natural formation. It is the signature of artificial foundation preparation. Bedrock leveled and compressed under sustained load. The report corroborates the existence of a massive pre-medieval structure without intending to. It was published as geology. It reads as archaeology. The French Ministry of Culture has managed the Notre-Dame site since 1906. After the fire of 2019, a complete geotechnical survey was conducted by the École Polytechnique to assess structural integrity for the restoration. The survey included ground-penetrating radar mapping of the foundation, core samples from the lowest accessible stone layers, and three-dimensional stress modeling of the subterranean load distribution. The results were classified in 2020 under National Heritage Protection laws. The classification was not temporary. It was not pending review. It was filed as a permanent state secret under the jurisdiction of the Ministry of Culture, with access restricted to restoration engineers operating under non-disclosure agreements. The data is not lost. It is not disputed. It is sealed. What that survey would show, if released, is the depth of the original foundation, the material composition of the lowest stones, and the date range those stones can occupy based on their load-bearing wear patterns. It would show whether the foundation predates 1163. The fact that it is sealed suggests it does. Acknowledging a high-technology pre-Gothic foundation beneath Notre-Dame is not an academic problem. It is a narrative problem. France's national origin story is built on the continuity between Roman Gaul and the Capetian dynasty. The Gothic cathedrals are the physical proof of that continuity. They are the first grand construction projects of a unified Christian France, the architectural signature of a culture emerging from the fragmentation of the early medieval period. If Notre-Dame was not built by the France of 1163, then the cornerstone of that story is someone else's work. The suppression is not a cover-up in the conspiratorial sense. It is an act of identity preservation. The mechanism is institutional, not secretive. Restoration contracts, excavation permits, and archaeological site access are controlled by the same ministry that manages the historical narrative. What gets dug, what gets dated, and what gets published are decided by the same authority. The process is legal. It is bureaucratic. It is effective. In 1847, a civil engineer named Eugène Belgrand was commissioned to map the underground water systems of Paris as part of the city's modernization program. His team documented the natural and artificial channels beneath the Ile de la Cité, including a network of stone-lined conduits running directly beneath Notre-Dame. The map shows a system of precise gradients, sluice gates, and junctions cut into bedrock. The channels were not Roman. Roman engineers used arched brick conduits. These were carved stone with vertical sidewalls and flat bases, achieving a 1% grade over distances exceeding 200 meters. The map was filed in the Archives Nationales. It has never been digitized. It has never been publicly released. Requests to view the original document require written justification and approval from the Ministry of Culture. The map is not hidden, it is managed. What the map shows is a level of hydraulic engineering inconsistent with any documented construction phase of Notre-Dame. The channels predate the Gothic structure. They were not built to serve it. They were already there. Notre-Dame was built over them. In the metro excavations of 1910, workers cutting the line beneath the Ile de la Cité exposed a clear stratigraphic boundary 3 meters below street level. Photographs from the dig show a visible line separating two layers, upper fill containing pottery shards, animal bones, and construction debris dating from the 12th to 14th centuries, and a lower layer of compacted stone aggregate with no datable inclusions. The boundary is not gradual, it is sharp, a physical threshold separating documented history from something older. That same boundary appears in excavation records from the Conciergerie Restoration, from the Palais de Justice Foundation work, and from the sewer expansion project of 1968. It is not unique to Notre-Dame. It is a feature of the island. The cultural layer is not metaphor. It is stratigraphy. It is the dirt line between the world we document and the world we build on top of. In 2017, a private restoration firm used laser scanning to create a millimeter-accurate three-dimensional model of Notre-Dame's interior structure. The scan revealed that the lower foundation stones, where accessible, were fitted to tolerances of less than half a millimeter across joints spanning 2 meters. The upper Gothic stonework, by contrast, shows joint gaps averaging 3 to 7 millimeters, consistent with medieval hand-cutting techniques. The more precisely the structure is measured, the more impossible the official timeline becomes. Laser scanning, ground-penetrating radar, thermographic imaging, and photogrammetry all produce the same result. The base is older, denser, and more precisely constructed than anything built in 12th century France. Our own technology exposes the historical fiction. Every new measurement tightens the contradiction. The precision itself is the weakness in the cover-up. You do not need to go to Paris to see this. Walk through the old quarter of any European city. Find a building older than 300 years. Look at the ground floor. If the windows are below the sidewalk, if the original entrance is now a basement door, if the first floor is submerged, you are looking at the cultural layer. The ground rose. The city was rebuilt on top of itself. But look closer. Look at the stone below grade and the stone above it. The lower section is larger blocks, tighter joints, no mortar. The upper section is smaller stones, wider gaps, lime mortar holding it together. That is the boundary. That is the same division visible in Notre-Dame, in the Conciergerie, in the Colosseum, in the foundations of Istanbul, in the old quarters of Edinburgh and Prague and Vienna. The two technology signature is not isolated to famous monuments. It is underneath the entire old world. The investigation does not end at Notre-Dame. It begins at the next street corner. Now we close the practical loop. Where did 100 monks go to the toilet in the middle of the night? They used a rear-dorter, a stone latrine block built as a dedicated structure separate from the sleeping quarters. The rear-dorter at Notre-Dame was a long rectangular building with a raised stone bench running its length. The bench had keyhole-shaped openings spaced roughly half a meter apart. Beneath the bench, a stone channel carried running water diverted from the underground system mapped by Belgrand in 1847. The water flow was continuous, fed by the natural gradient of the Seine, and controlled by sluice gates that could be opened to increase flow during heavy use or closed to prevent freezing in winter. The system required no manual cleaning. Waste dropped directly into the channel and was carried away beneath the island, eventually emptying into the river downstream. At night, the monks moved in total darkness. Candles were forbidden after Compline under the rule of Saint Benedict. Speech was forbidden. To navigate from the dormitory to the rear-dorter, they followed guide ropes fixed along the cloister walls. The ropes were thick hemp, replaced annually, anchored at chest height. A monk could walk the entire route by touch. No light, no sound. In some sections, the rope was replaced by a polished stone handrail carved directly into the wall. The path was memorized during daylight and repeated in darkness. The system worked because it was predictable. The same route, the same sequence, the same tactile landmarks. For monks who had lived in the same cloister for years, the path became automatic. Muscle memory replaced vision. The underground channels themselves served as an acoustic waypoint. The sound of running water echoed up through stone vents built into the floor of the rear-dorter. A monk approaching in darkness could hear the water before he reached the door. The sound confirmed he was in the right place. Inside the rear-dorter, vertical flues carved into the thick masonry walls vented sewer gases to the roof. Louvered openings at the top of the flues prevented rain from entering while allowing continuous airflow. The result was a latrine block that, despite serving 100 men, did not smell. The engineering was passive. No pumps, no maintenance. Just geometry, gravity, and water. This is not speculation. This is documented medieval sanitation engineering, applied at scale. The rear-dorter system explains the thermal anomalies detected in the 2017 scans. The underground water channels created temperature differentials that registered as heat signatures on infrared imaging. It explains the acoustic properties of certain floor sections that produce unusually strong resonance when struck. It explains the unexplained voids beneath the cathedral floor that do not correspond to any known crypt or cellar. Those voids are the channels, still there, still flowing. History is written by restoration committees. Stone was not consulted. Stone holds the original specification. It does not revise its tolerances to fit the current narrative. The measurement is still there, waiting. Bedrock.